Good morning, good afternoon, good evening, ladies and gentlemen. I hope you've been having a wonderful, fantastic, amazing day. And in today's video, we're going to look at common factoring. Now, first off, when you are factoring, you want to ask yourself, is there something that I can divide both of my terms by? Now, to remember what a term is, you're going to want to go through with the box method. And what the box method is this. So you start off a box at the beginning of your term. You continue this box until you get to your first plus or minus. So as you can see here, I have a plus. So I stop my box here. That's my first box. Then you start your next box after the plus or minus and continue until the next plus or minus or the end of your term. These are basically called my terms. So in this equation here, I have two terms, the 3x and the 6. So the first question you want to ask yourself is there anything I can divide both, it's the important part there, both terms by? This is what they often call the lowest common multiple. Which is basically the biggest number I can divide them both by, or the biggest exponent. So let's take a look at this. Let's look at the numbers first. So we have a 3 and we have a 6. Now, obviously the factors for 3 are 1 and 3, and the factors of 6 are 1, 2, 3, and 6. So you have to look at this and you have to ask yourself, can I divide the 3 by 1? Yes. Can I divide the 6 by 1? Yes. Will that do anything? No. So you move on. So I look at the 3 and I say, can I divide 3 by 3? Of course I can. Can I divide 6 by 3? Absolutely. 6 divided by 3 will give me 2. So we've identified here what we call the lowest common multiple because I can divide both of these by 2. So by 3. Ooh, sorry about that. Old man memory. So you take the 3 out. And what we're doing here is you take the 3 outside and then you draw a bracket. It's kind of like 3 got kicked out of the house and he's banging against the door. What's left inside the house? Well, let's see. So what's left inside the house? Well, you then have to ask yourself, what do I have to multiply? So what do I multiply by 3 to get me 3x? Well, 3x, if I wanted it to get from 3, I'd multiply the 3 by x, because I know that 3 multiplied by x gives me 3x. Okay? And that's just a squiggly line on top of the x. That's just nothing. Don't write that down. Now, then I put the plus because there's nothing happening to the plus. And then I have the 6. Well, what do I have to multiply by the 3 to give me my 6? And now imagine, it's like the 3 is the shopping bag. You put the 3 in the shopping bag. What's left over when you took out the 3? I'm not telling you to do 6 minus 3. I'm telling you to do 6 divided by 3, which I know is 2. Now, how do I know that this is right? Well, you have to ask yourself, is there anything inside the bracket that I can now take out? How do I know that this is fully factored? Well, let's look. The x and the 2, do they have anything in common? No. X is a letter, 2 is a number. So I can't do anything with that situation. So this is my final answer. How do I know I'm right, though? Well, you'd have to do what we call distribution. You want to kind of do this in reverse and see if you get what you started with. So let's do that on the next page. So how do I check if I'm right? Well, to check if you're right, you have to do distribution. Now, distribution, as I showed you guys in the other video with my horrible, horrible example of Pokemon Go, remember the 3 would have to multiply both terms. In essence, it has to catch them all. I've got to catch that Pikachu. I've got to catch that Bulbasaur. So, by catch, I mean multiply. So, 3 times x is 3x. I've caught my Pikachu. Pika Pika. 3 times 2 is 6. I've caught my Bulbasaur. Or did I say Charmander? I don't know. Can't keep them up. Now, is this what we started with? Yes. This is what this is, grammar is a bad thing, is what we started with. And because that's what we started with, we can say that we have factored it, and we factored it correctly. I hope this has helped anybody when it comes to common factoring.